requirements are here.
No.
That's why we will take through them.
Okay.
So whenever you know exact value one thing, then you can take it. Otherwise, consider the value.
Oh, got it. Thank you, Karthik.
What?
Hi.
Yes, sir.
In this session, we are going to discuss about container
Hi,
orchestration
Karthik.
using
Karthik,
Kubernetes. While we discuss about Docker
base of
containers, we discuss about containerization and
this is
virtualization
the
in detail,
constant factor.
and we saw
So
how we can implement
time
containers
complexity
using
can
Docker
be
tool.
should be low and
So
can be
when
more
we discuss
base
about lot of
base
containers having
and
intercommunication
Base
requirement,
is never be
about their
separate part of
networking, about
load
their
one.
storage management and all, port
Differentiate
forwarding,
this is log and
application intercommunication,
always be
services,
divided with its piece.
microservices. So
Otherwise,
containers
it
were
will be
intended to
considered as a
implement all
nature.
these kind of services and communicate together
So
without
this again.
whether they are placed on
जब
the
भी मैंने
same VMs
देखा
or they
लेकिन
are
टाइम कॉम्प्लेक्सिटी क्या
deployed
है
on
उसकी log n
multiple
है
VMs.
बल्कि
But
केस
doing this
वगैरह
task
वो
in
मेंशन
IT
गलत
was
होता है
actually a tedious one
वो गलत होता
because
है। So
applications were divided into smaller modules
या
in
फिर
terms
हम
of
उसको ऐसे
microservices,
डिफाइन किया होगा
and the deployment
कि
of
वो
them
नेचुरल बेस्ड
on multiple VMs
नेचुरल
for the
बेस्ड
sake of resource utilization, management, intercommunication,
हाँ
connecting,
तो
accessing
शायद
pop
मैंने
out
ये सुना था
from
कि पिको
outside the
नोटेशंस में
VM
शायद ये
was a
तो
tedious
हम
task.
इसको इग्नोर कर सकते
And
हैं
then came
नहीं
requirement
वो
of container orchestration in picture. Google developed this tool in order to manage containers effectively and with lots of features provided by Kubernetes so that we have a hassle-free container deployment and orchestration in our IT. So let's see what is the agenda in this session that we are going to cover. We'll be discussing about Kubernetes, how it came into existence, who developed, and when was it the first time it discovered. Then we will discuss about Kubernetes architecture. We will see what are the various mode of Kubernetes installation in our own IT environment. We will also discuss about various Kubernetes components, deployments, and all objects in Kubernetes are written in YML files. So here we will see how we can manage Kubernetes deployment pods by using YML files.
Monday, Wednesday,
We
Friday.
also see what services are in
Just check with
Kubernetes, what
us.
type of services exist, and how we can implement services that we will see using hands-on demo.
Anything else?
We will also see an important topic in Kubernetes that saves a lot of cost in Kubernetes environment, and that is ingress. So these are topics we are going to cover in
Okay,
detail.
so
The
quick,
first
like,
topic
how
is
is this session?
introduction to Kubernetes that we will discuss in this session.
So that I can improve.
What is Kubernetes? Kubernetes is an open source container orchestration software. It was originally developed by Google
You guys
and
like
it was first
something
released
like this. Okay.
on July 21st, 2015. It is the 9th most active repository on GitHub. Remember our first session about GitHub where we do manage source code controls. Source code actually. So GitHub public repositories are where open
Next
source
topic
projects
will
are
be this,
managed and
name of
everybody
it.
who are
Two more
working
classes
on them,
are
using them, willing to contribute to the project, actually pull the code of the existing environment, existing software and make their development and push the code for evaluation and
Okay, guys.
submission.
Thanks, everyone.
And if their features are good,
Let's
a well introduced feature, a well functional feature that can be introduced in the product itself, then the community actually accumulates those challenges to the next release of the software. So this is where we see most of the ITs who are using Kubernetes or containers are actually using Kubernetes and contributing them as well. So that's where Kubernetes exists as a 9th most active repository on GitHub in terms of number of commits. Commits means changes the people are doing on the Kubernetes software. So this is how Kubernetes came into existence, and this was all about Kubernetes. But let's discuss about orchestration. What is orchestration? As I said, when we moved from virtualization to containerization, before that, for virtualization, we had a lot of softwares like VMware, VirtualBox, or VMware was a big provider in for virtual machine management software that was named as a VMware. So when we came to containerization using containers, tools like Docker, Mesos, Rocket. So these kind of software actually started deploying your application in terms of containers. Lot of containers were deployed even for one application. How? Because your monolithic application, when we say monolithic, that means your front end, your back end, your databases are tightly coupled and they are part of the single development. When we talk about microservices, which was the next evolution where we started moving monolithic application to microservices application. So here what we do, here we divide every component of application development in terms of module. Like we separate front end, we separate back end, we separate databases, and we try to deploy them as an independent service in terms of containers. So that's where we see even for one application that has maybe 10, 9 features, 15, 20 features that may be converted to modules, and then they can be deployed in terms of 20, 30, 50, 100,000 containers. So that's where we see how it can be difficult to manage these number of containers when they are running in numbers. So that's where the need of container orchestration came into picture. Why we needed to manage the containers? We needed to have communication among them. Front end need to talk to back end need to talk to databases. In middle we may have messaging service. So these all kind of containers needed to communicate to and fro in order to serve the end users, right? So this was the need of having container orchestration so that their ports, their services, their storage volumes, so to which they are connected, the syncing, the replication, the backup and storage, all kind of needs were required to be managed in an effective manner, and that's where need of container orchestration came into picture. I hope now we understand the need of container orchestration in detail, why we needed this kind of software in the market. Google understood the need of this container orchestration, and they were already working. They were using this software internally, and when they felt the need of means releasing this software to the market, because they saw like people are more oriented toward container deployments, and they are seeking for this kind of software. So that's where Kubernetes came into existence, and people started using it very aggressively. So let's see what features Kubernetes offers actually. It has pods. Pods are smallest units in Kubernetes, and they actually contain or wrap your containers in one unit. Then comes replication controller that is used to maintain the replication of pods, replication of deployments inside your environment. Then comes storage management, how you can manage volumes, how you can manage file system in Kubernetes. That is part of the storage management inside Kubernetes. Resource monitoring is again one feature because you are deploying a lot of containers in terms of pods, and Kubernetes needs to manage the intercommunication, networking, storage, volume, file sharing, everything between them. So resource monitoring and resource uses based on the CPU, memory, file system space, everything was needed in terms to provide high availability inside the environment using Kubernetes. Because in coming sessions we will learn pods can be scaled whenever load increases, and they can be scaled down whenever load decreases. So these features are managed by Kubernetes automatically, and that's where resource monitoring was needed to take the required action, scale up, scale down, or scale in or scale out. Then comes health checks. Health checks are required to serve the active pods which can take the load. If some pod is having issue, it will be demarked from the service, and new pods will be started based on the resource utilization or maybe other metrics that you have provided. So that's where health come into picture, which provides active routing among the pods that are healthy. Service discovery is again one feature where whenever we are deploying new pods or we are scaling up, so it will discover which pod or deployment can provide the services to the external application or users. So this is where service discovery comes in picture. Then comes networking, how your pod's going to communicate, how port forwarding, how networking rules, what will be the IPs of every pod, deployments, right? So these kind of uh, services are managed by the networking feature of Kubernetes. Secret management is one important thing where you want to maintain your credentials hidden from the external users. So that's where secret management comes into picture, where you can mask your information to be used by pods only, and that can be read by pods only and it should not be exposed to the public. And then comes a very important feature, rolling updates. Nobody likes the downtime in their deployments, in their IT environment. We want 100% availability. And that's where Kubernetes tried to achieve 99% availability, 98% availability without any downtime, without any issues, and without any manual intervention. That's where this rolling update feature came into picture, where whenever you are performing any upgrade or releases, you do not need to bring down your own IT infrastructure. Rather, you get new version deployed simultaneously, and it will start taking loads gradually. Means your application load move from version 1 to version 2 without sensing any downtime in the environment. And that's the very strong feature, and you can say favorite feature of the Kubernetes that attracts customer in the market. And this is the major reason of getting the popularity in IT. So these are some important features that I tried to project here. In coming slides, we will saw these features in detail and we will try to replicate some of the scenarios in hands-on sessions. So this was about in first topic about Kubernetes. Next, we are going to discuss about Kubernetes architecture. So let's see how Kubernetes architecture is designed. Kubernetes actually works in master-slave mode, where we have one master VM running, master node running, which is called control plane, and from where we manage all the deployment, services, configurations on our connected slave nodes. Slave nodes are called worker nodes also. So, what is the role of slave nodes here? Slave nodes are the VMs where we deploy our pods. What are pods? Pods will actually have our application deployed in terms of microservices. So we need slave nodes in order to host or deploy our services, and that deployment, networking, everything will be managed by our Kubernetes control plane that will be here. So every time your worker nodes need to be connected to the master node whenever you want to manage your services deployed here. Sometimes your master node may go down. That doesn't mean your services will go down on slave node as well, because they are independent of the master node. Master node is there only to manage your Kubernetes deployments, Kubernetes operations. So until my master node is down, you will not be able to perform any operation on the slave nodes. But even if it is down or not connected to slave nodes, the pods and deployments will run without any issues. But you can't make any changes between the unavailability of the master node. So every master node, we may have multiple nodes, multiple master nodes also, or we may have like master node cluster as well, where we have active or active passive master node configuration in our environment in order to provide high availability. So whatever model we follow to deploy our master or control plane in Kubernetes, every master node will have these components that you can see on my screen. It need to have one Docker support, one container support tool. Favorite one is Docker if you want to deploy our own. Otherwise, there may be other kind of container engines can be used. If you talk about Kubernetes do not use Docker as a default container engine. So that's where even if you go about managed Kubernetes services and all, you will see Docker is not present, and it works without Docker. It has own container engine. And even from Kubernetes version 1.20, Docker support is removed. So, but for understanding and for running, even this is hard, like we will be deploying our own Kubernetes cluster in IT environment in bare metal machines or local data center, while most other people prefer to deploy Kubernetes on or use Kubernetes managed services on cloud service providers. We will see a lot of options are available, but yes, we need to know the architecture how Kubernetes works. So master nodes have one container engine, one etcd, API server, scheduler, controller manager. So majorly we have 5 components inside master node. Similarly, every slave node deployed need to have 3 components, one container engine like Docker, one kubelet and kubeproxy. These 3 components need to be available on every slave node in order to talk to master node and serve deploy Kubernetes services to the applications. So this is how we can see the components that we need to have that are present inside Kubernetes architecture. In next session, we will cover each component in detail. So let's discuss about every master component in detail. First is etcd. We call it etcd key value store. It is a highly available distributed key value store which is used to store cluster-wide secret. In general term, we can say all Kubernetes deployment or cluster configuration details are stored in etcd. This need to be highly available, and it should not go down. If you need to recreate or you need to manage your deployments or manage your cluster configuration, then it need to be available all the time. So this is where it will have all the information of your configuration is stored, and it is only accessible by the Kubernetes API server, and it has sensitive information. You cannot access etcd directly. It is designed in such manner. So next is API server. API server exposes Kubernetes APIs. APIs are application programming interface and endpoints where using which you can access that particular service for which it is meant for. So Kubernetes API is the front end for the Kubernetes control plane. Control plane is your master node, and using API only you can access the master node services, and it is used to deploy and execute all operations in the Kubernetes. In order to ensure services deployments on slave nodes of Kubernetes, you need to have API server running. This is required because it actually this is a place where all APIs, your etcd components API endpoint, your nodes, your worker nodes, your all pods information, their communication IPs, or you can say their DNS, everything is registered to this as an endpoint, API endpoint to this API server, and using which, first of all, you connect to the master control plane using this API server only. It gives you an endpoint to connect to the master node or control plane, and from where, again, whenever you are firing any command, any action on the slave nodes, then this API server will only come in picture as a first layer in order to communicate to the other component inside Kubernetes. So this is how it is actually important component in order to manage all communication with the components inside. Then comes scheduler. The scheduler takes care of scheduling of all process and the dynamic resource management, and manages present and future events on the cluster. Scheduler is, as the name suggests, it is responsible to schedule services and objects on the worker nodes when asked, or as per the schedule it has. Like you have deployment running, and whenever a new pod need to come in picture, suppose you got one VM where you had resources for 5 pods only. So this is your VM. It has resources, suppose 5 CPU and 5 GB RAM. Now you have deployed pods here. Each pod requires 1 CPU and 1 GB memory, right? Pods are having containers, and they are like servers only, are lightweighted servers, and they require same type of resources as your VM needs. So as per the total resource, if you see, we can deploy only 5 pods on this machine. Suppose your application need to scale up and go up to 10 pods or 7 pods. Now, where these two more additional nodes, additional pods will be deployed, they will look for another worker node or slave node in the cluster. This is your Kubernetes cluster. Okay, so this is your Kubernetes cluster, and it will have worker nodes that will be acting as a cluster of VMs that will be hosting or deploying your pods based on the resources they need. So since our first node is full, it will look for another VM that is having resources and their pod can be deployed, and which is part of the cluster most importantly. So now these two pods can be deployed here, but who will take care of these things? These things actually are taken care by the scheduler. So this is where scheduler is important. All the scheduling of pods, services, these daemon sets are actually managed by the scheduler component of etcd. One important thing that I want to tell you here about Kubernetes name. Kubernetes is actually called K8S also. K8S. And this 8 comes from 1, 2, 3, 4, 5, 6, 7, 8. So this is where K, 8 and S is called K8S in short. So this is a tip that I wanted to share here. Let's go back to the slide and discuss about next component as controller manager. The controller manager runs all controllers on the Kubernetes cluster. Although each controller is a separate process, to reduce complexity, all controllers are compiled into a single process and they are as follows. So Kubernetes have default controller managers, default controllers in Kubernetes cluster that are running on the master node, and they have dedicated tasks. This is not one entity, they are multiple entities, and every entity has their own task. Like node controller will control your nodes, replication controller will take care of replication among the pods, replication of the pods and all. Endpoint controller will take care of the endpoint APIs that are going to register on the API server. Service accounts will be used to provide the access to the services, because in Kubernetes actually we define service accounts based on user, or you can say authorization, that we give authorization in order to access pods if you want additional security. So that's where service account controller comes into picture. Then comes token controller. Token controllers, when you want to access some services based on token based authentication, then token controllers take care of these. Even internal to Kubernetes, tokens are used for internal communication, and that's where token controller comes into picture. You can deploy your own custom controllers in Kubernetes environment, and that is part of the again additional learning that we can go for. So this is the role of controller manager here. Again, container engine that I discussed, like Docker or any other tool that you need to have on masternode, is again important. And without this, your containerization of pods will not be able to run. So apart from these all 4 components, you need to have container engine also deployed. That can be either you deploy or you may be using managed cloud services, managed Kubernetes services on cloud, then they will be part of your managed cluster itself. So this is also important to run your pods. Pods are nothing, they are collection of containers in Kubernetes deployment. Fine. This is pods we are going to cover in next session. So this is all about detailing of master components in Kubernetes. Next topic we check on slave component detail. In this session, we are going to discuss about slave components details. We already discussed about master components, which are 4 or 5. 4 are major and one is container runtime, that is need to be there in order to deploy your pods. That is again an important layer inside master node. Then coming to slave components, these two are like that need to be running on slave nodes are kubelet and kubeproxy. Again, because every master or every slave node will have pod deployed and pod contains container, so Docker runtime or any other container runtime is also highly required. So these three components we need to have in slave node, every slave node that is part of the Kubernetes cluster. So what is kubelet? Kubelet actually takes the specification from the from the API server. API server, I already told that your kubelet or your slave nodes talk to master node using API server. So whatever communication configuration comes from API server, kubelet actually take from the API server itself, and then they ensure that the application is running out according to the specification. First of all, from where these specifications are coming? These specifications are actually written inside YML files. So they can also be internal definition, like internal configuration, because Kubernetes also deploy their own cluster pods services in order to make the cluster running. So that's where these configurations are stored in HCD. Also, because it is meant for application, for user applications, so that's where user can also create the deployments configuration that will be coming from user directly. How? User can write their configuration in terms of YML files. If you remember, YML we have discussed multiple times. We discussed about Ansible, we talked about YML, and even in Docker, we can manage your Docker Compose and all containers using in Docker Compose using YML files. So YML are very user friendly, and we can say like they are readable and easily learnable. So that's where YML is used everywhere now in new DevOps tools to manage the configurations. So that's where we can write our configuration in terms of various YML files, and we also need to define which type of configuration it is when we are defining the YML file. So using these YML files, we can use apply kubectl apply command. You will see in the hands-on exercise, kubectl is the tool that is used to control the execution. That is a command line tool that is used to manage your Kubernetes cluster and deployments. So using kubectl apply, you can deploy this configuration in Kubernetes, and from where they will be registered to the etcd and they will be created onto the slave nodes. Now when these configurations are applied on the cluster, your API server will push this kind of information to the slave nodes, and there kubelet will actually picks this kind of specification or configuration from the API server and ensure that this configuration is done on the slave nodes based on the details. And not only creation, not only deployment, it also take care of their running on the cluster as per the deployment file or specification. Suppose you want 3 replicas of pod to be running on your slave nodes. So kubelet will ensure these 3 are running. These 3 pods, replicas of that pod, are available all the time on the cluster, and they are healthy and live. So this is a very important service or component of every slave node in order to make your node alive and healthy. So that's where each node need to have their own kubelet service locally, right? So this is the need of kubelet on slave nodes. Then comes kubeproxy. Proxy we understand that which is needed to mask some information, which is not directly which is actually hiding some information behind. So this proxy service runs on each node and helps in making services available to the external host on some address, proxy address. Okay, so it helps in connection forwarding to the correct resources. It also capable of doing primitive load balancing. So whenever we are deploying pods or services, we need to forward external communication to those pods or services effectively, right? So that these services are discoverable to the outside cluster, maybe master or other nodes. So how it is made possible in the Kubernetes cluster? This is made possible using kubeproxy, which makes your services available using port forwarding or other proxies defined to the external entities. These entities can be part of cluster, can be outside. So this was all about slave node components. Yes, Docker engine or container engine will again need to be available in order to schedule your pods and containers. That's where three important components are there in Kubernetes slave nodes environment. Next, we discuss about Kubernetes installation, what are ways and how we can do in our own VMs. Till now, we discussed about Kubernetes and its component and architecture. In this session, we will see what are the various ways to get Kubernetes installed in our own environment. So, because it is open source, everybody is exploring new features inside Kubernetes and they are trying to use it in their own IT environment. So that's where every means a lot of vendors or lots of users have discovered multiple ways to install Kubernetes. Out of which one is kubeadm. Kubeadm we use to do kubeadm installation on our own virtual machines or physical machines. So machines, bare metal, it can be a bare metal installation on both type of servers, like physical or virtual, both. Then comes Minikube. Minikube is a small package which, or we can say a small tool that actually gives you virtualized environment on your own VMs. Even if you have a one VM, you can deploy Kubernetes cluster on it using Minikube, and it gives you option to choose which type of virtualization you want to your Kubernetes deployed. It can be Dockerized environment, it can be virtual machine environment, it can be hypervisor environment, or multiple types. So when you go for Minikube installation, you will see it will ask you which type of virtualization you want for your Kubernetes installation. Then comes Kops. Kops is actually meant for Kubernetes installation on AWS. AWS means Amazon Web Services, which is a popular public cloud available to the users. There you can go, you can have managed compute engines, and there you can install your own Kubernetes cluster. Then comes Kubernetes on GCP, where you can deploy your own Kubernetes cloud or you can Kubernetes cluster on Google Cloud Platform using Google Compute Machines. So these are kind of installations where you will see you have to install your own Kubernetes installation. Then comes managed Kubernetes services, where you do not need to install Kubernetes. They are already available as a managed services in public cloud or various other Kubernetes service solution providers. Just you need to go create your cluster and start using it. So Kubernetes is also available as a service on cloud platforms. So I have given some examples here, like Amazon as a largest cloud provider has its own managed Kubernetes service, and which is named as EKS, Elastic Kubernetes Service. Similarly, Azure have their own, they have named it Azure Kubernetes Service. And again, Google, it is a Google product. So the first managed Kubernetes cluster was deployed and made public by Google itself. So, and they have named it Google Kubernetes Engine. So that's where we have other small, like we have Kubernetes cluster means service, Kubernetes as a service from Katacoda, from DigitalOcean. These are small vendors also, solution providers are also available to give you Kubernetes as a service, and where you can go and create just cluster by with a given name and deploy your workloads on top of them. So with the evolution of cloud, managed services, software as a service, Kubernetes is also available as a service on clouds, and you can go and start using them. You do not need to install them on, or you do not need to install them from scratch on your VMs. So in next session we see about the hands-on on installing one of the option of installing Kubernetes, that is kubeadm. We will have 2 virtual machines on Google Cloud, and we will try to install Kubernetes on these 2 virtual machines. One will be worker node and one will be master node. Last session, we discussed about various ways of installing Kubernetes in your own VM, or you can use manage Kubernetes services on various public clouds. Now we will see one of the way of installing Kubernetes in your own environment using kubeadm. So let's go. I have one document prepared for the same. That's what I am going to follow. So what we need to do, we need to install some supporting components, dependencies on both the machines. One I am using here as a master node, and one machine I will be using as slave node or worker node. So for the sake of time saving, I have already created two servers. One is my kube master, that is master node, and one is kube worker, which is a slave node. I'm logged into both, and this is my master node VM, and this is my worker node instance. Okay, so the first set of steps I need to run on both the machines. Okay, so I need to first refresh the repositories. That's what we do before installing any new system software or software on Linux machine. Then we will install Docker as our container runtime. We are going to use this. Then comes we need to update our repository and install some dependencies like transport HTTPS, this package, and curl package in order to access APIs or URLs. So using curl that we installed in the previous step, we are going to get the GPG key added from packages.cloud.google.com, and then we will append the Kubernetes repo list. This is the path of the Kubernetes installation, okay, into our Ubuntu software repo. So this is how we are going to do it. Once software repo is appended with the Kubernetes package URL, we need to update again and then install kubelet, kubeadm, and kubectl tool from this repo. Okay, so these are all steps we are going to do. First, let's update the repository on both the machines. So this I need to run as a root on both the machines. So I will use this command. I have become root. Of course, you need to be part of root, then only you will be able to switch to the root account and then run this update. You can use sudo also, like we did it for earlier, but because we need to run multiple commands here, I will simply log in as root and run every command. If you are part of root, you can append sudo against every command here like this, and you can run with your own user also if it is part of the root account. Once repo is refreshed, let's install Docker as container engine on both the machine. I need to confirm by pressing yes. Then run update again and install HTTPS, transport HTTPS, and curl software. So because it is running and installing Docker installation, so I will need to wait till installation completes. One more step we will need to add our user account to Docker group. That's what we did in the Docker account. If we need to test any container or we launch any container outside the Kubernetes. So for the safer side, that step also we will perform here once Docker installation is complete. So until it is taking time, let's go back to the document and I will explain you further steps. So once we have installed all the components, so there are, if you see, majorly we are installing 3 components on both the machines. So they are aligned with the architecture of the Kubernetes, where we need to have kubelet on all the connecting node. So this will we will install on slave node as well as master node. Majorly it is required on the slave node only. Kubeadm we will be installing because here we are going to install our Kubernetes using this kubeadm. This is why kubeadm is required to manage our Kubernetes cluster, install and manage our Kubernetes cluster. Then kubectl, a component we are installing here in order to give us facility command line tool to manage our resources from Kubernetes or server command line on Kubernetes in cluster. Okay, so now our Docker is installed. So what I will do, I will add my Ubuntu user, because that user I will be using, remote-ag into Docker group. This user I have here. Similarly, I will add this user on my other node also, on my master, so that in case I need to run Docker containers, I will be able to do. Next is now installing these packages, curl and apt transport https on master as well as slave. This shouldn't take much time. Next is adding gpg key on both the servers. To add my kubernetes URL, must check the output, it should be okay always. Then comes adding repo to my software repo of Ubuntu, added. Okay, so it is just creating one file with Ubuntu repo in source repo, source list.t. Okay, then next is, once I have added one repo, I need to refresh the repository and go with the kubectl or other components installation. This shouldn't take much time. Yeah, this is done. So now the last step, you will install all these three required softwares: kubelet, kubeadm and kubectl on both the servers. You see, the installation was quick, and once it is installed, yeah, it is installing. It is still installing, and it should be done in a minute or two. Yeah, so this is installed, and let's see if everything is installed correctly. kubectl hyphen version should give me kubectl version. Okay, yeah, so kubectl is installed correctly, and for version I need to just mention version, should not be hyphen or hyphen version. See, so kubectl is client version installed, and this is major and minor, all details are showing here. Similarly, I can check for kubeadm. kubeadm is also installed, and one kubelet I also can check. Perfect. So everything is installed. Next, I have checked this kube version client and kubeadm version, both are checked successfully. On the second server also I can check kubectl version, fine. kubeadm version, fine, right? So both the servers have required software installed now. Next step is required to be performed on master, where we need to create our control plane to manage the Kubernetes cluster. Here I will initialize my Kubernetes cluster using kubeadm init. The command is looks a bit complex, but it's easy to understand. What you need to give? You need to give kubeadm init -- API server advertise address. This will be your master machine's IP address. Then pod network CIDR block. Here means your which subnets your pods need to follow when pods are getting created and their IP assignment need to be done. That CIDR block you need to define here. For here I will be using this one. So your all pods that get created inside your cluster will follow IP pattern starting with 192.168. something, and then I will mention some ignore error pattern. So let me get the IP of my machine first. Using if config -a, we can get the IP of our machine and place in the command. Now the IP is updated in the command that I shown you here in this. Now we can run this command in order to initialize the cluster. This may take 2-3 minutes because it executes a lot of things and set up various components in order to make the Kubernetes work. So here it will be pulling multiple images, it will be creating required groups, and it will place lots of manifest files in order to support Kubernetes working and deployments. So here you can see the square bracket show you which section of action it is performing. Pre-flight, then certs are getting generated. Certs will be used to ensure secure communication among the Kubernetes objects, components, and then you can see various certificates are getting generated here at various locations. For HCD CA, HCD server, front proxy CA, certificate CA stands for certificate authority. And then for HCD server, serving cert is signed for DNS, Kubernetes kube master localhost, and IPs are this. So the IP of this, you can see the same IP has been registered for kube DNS functionality. Then kube config sections is getting run, where kube configurations are getting created inside etc kubernetes, where admin.conf is getting created for admin related configurations. Kubelet conf will be used here for kubelet means for pod configurations, for kubelet functionalities, controller managers. So every component you can see getting created here: kubelet conf, controller manager, scheduler, that we discussed in the master components, right? Then it is writing creating kubelet start sections, where in this kind of files var lib kubelet config.yml. Then starting of the kubelet is being done here, and which is actually which will manage your slave nodes deployments. So this way lots of actions were done and can be seen inside the log of the Kubernetes cluster initiation, and at the end you will see the message that your Kubernetes control plane has been initialized successfully. This is not the end. At the end of the initialization of the cluster, it will give you some actions to be performed when you are going to run with the other user than root inside your master node. So if you are going to run this using master regular user, that's usually we do. So in 3 steps you need to do. The first is creating kubeconfig directory, where you will be placing this admin.conf inside your kubeconfig. This admin.conf contains your cluster details, the name of the cluster, or the configuration, IP, everything to which you need to connect and perform Kubernetes operations. So that's where this file is important to be placed in your home directory inside .kube folder. So by default Kubernetes will look in this location only, your home folder, .kube directory and config file. Then you need to change the permission of this file for your ID. Then this is alternate of this. You can export your kubeconfig file using this variable also, kubeconfig, that is also an option. And at the end, this is your master node ready. Now you will definitely need to join your slave nodes. So this is the command that kubeadm gives you at the end of the cluster creation, that you can use and create your own and join your slave nodes. So this is command I am saving here that I will run on my slave nodes that I have here, worker nodes, right? So on root user only I need to run this command. Do not change the user, because this will be using permissions of using files that were created by the kubecutter. Okay, and this list when you have run this command, you will see at the end of message that this node has joined the cluster successfully, and then you can check if on the control plane you can run this command kubecutter get nodes if this node is part of the cluster or not. That you can check from the master node. Also, if you want you have your cluster ready, so you can check your cluster information using kubecutter cluster info command. So now for running all operation on your command, so you need to use kubecutter. Okay, so this way, sorry, some issue with this. Oh, sorry, I have not run this. These are the steps that need to be performed by changing to the normal user. So that step actually I missed here. So let's change to my Ubuntu user, from which I will be running all Kubernetes operations. So let's go back there, run all these commands, make sure user has changed. These 3 commands I can run one go, and then I can check kubecutter cluster info, right? And you will be able to see your cluster detail, control plane where it is running, what is the DNS address, and other things. So Now my cluster is working fine. I can check my connected nodes also using get nodes command, and you can see 2 nodes are available here but not ready. Both the nodes are not ready situation. Rest, you can see what their roles. One is your master, other is worker with no roles, age and version, which kubectl version they are running. So what next? Why they are not able to communicate? Why they are showing not ready? Because the networking setup that is required for pods to communicate, we need to create using container network interface CNI plugin. So there are various plugin options are available like VNet, Calico, out of which we will be using Calico here to support my networking related informations, right? Networking related configuration. How we can do? All Calico configurations have been bundled in form of Kubernetes deployment in a YML on this location, and kubectl provides you a facility that where you can deploy any file using kubectl apply, whether it is placed locally or it is placed on the public API, public internet. So this file, YML file, deployment file is located in this URL, which I can fetch using kubectl apply and directly deploy in my cluster. So let's run this. By default, it will create all these kind of objects here. You can see custom resource definitions, various CRDs that are written in Calico to support network operations that are deployed, config map created for Calico, cluster roles, role bindings, authorizations, role-based access control, RBAC, daemon set, service account, deployment, service account, pod disruption budget. These are, every term has a meaning here in Kubernetes environment. So we will discuss few of them in detail in coming sessions. So let's see where this deployment got deployed. Every deployment gets, I do not give any namespace in this YML file. So by default, it will deploy in default. But here in this YML file, it already have a namespace named kube system. So you can check this deployment in namespace. Namespace we give using hyphen n and then the namespace name. So in kube system namespace, you can see Calico kube controller has been deployed 65 seconds ago. How you can check which namespaces are part of your cluster? Using get ns or get namespaces. So this is where you can see 4 namespaces are part of my cluster, right? So Calico plugin is deployed. Now we can check again what is the status of my nodes. See, after deploying the networking requirement CNI plugin, our net nodes are able to communicate and they are in ready condition. Same I can check on my worker also. Since I have kubectl deployed here, generally we do not do anything on nodes, but since I have kubectl deployed, I can run it. But most of the operation will not be supported until I put my kubeconfig here. Kubeconfig file can be used that I placed in my Ubuntu user on master control plane can be put in here and can be used to connect to the cluster and run all the requirement as a separate VM. So ideally it is not suggestible, but kubectl provides you facility that you can use config file and connect from anywhere. So this practice you can follow and run, but from worker node, I will not suggest to do it. We should not be doing anything apart from resource management on worker nodes. If I run this command here, you will see connection was refused because it is checking nodes on local server. I have not defined kube config here. I need to copy that file and then run all these steps here that support that will configure my cluster details on node 2 or slave node. So here if you see these steps need to be run there also. If I can copy this file to the worker nodes, and same operation can be done on any machine. As I said, this config file if I have, I can connect to this cluster from anywhere if this is public. If this is private, then I need to provide authentication mechanism also, authentication credentials to connect to that private cluster, but the mechanism remains same. So this way my cluster is set up, and this all I was able to do successfully. So this is a basic way of installing Kube ADM or Kubernetes cluster using Kube ADM in your environment and run Kubernetes deployment. The next session we cover about various components of Kubernetes deployment like pods, deployment, services, ingress in detail. So let's keep tuned and keep learning. In last session, we checked about installation of Kubernetes using kubeadm in our own environment. So since we have a kube cluster running in our VMs, let's see how things work inside Kubernetes. So first we will talk about pods. Pods can have one or more containers coupled together. So by this way, we can see containers are not deployed directly inside Kubernetes. Rather, they are bundled inside a pod, and pod takes care of the containers deployed. And this way, pod is considered to be a basic unit of Kubernetes. To increase the high availability, we always prefer pods to be in replicas. That means if we have application pod deployed inside Kubernetes, we can have more than one replicas of the same application pod running inside the kube cluster. So this is a reason Kubernetes deployment, so Kubernetes architecture considered to be highly available because it supports redundancy at pods level and other components level as well. And these pods, based on the deployments, replications, they can be scaled up, scaled down based on the strategies that you define. They can be this scale up and scale down can be done automatically using the replication and all, using the deployments, using the auto scaling inside Kubernetes. So there are various, just the things that we are learning are very basic things. There are a lot of things that Kubernetes gives you in bundles to give you lots of automation benefits, including authorization and networking, volume management, port mapping, storages, backup, permissions, role-based authentication. So these kind of means various features for Kubernetes provide you. When we learn towards various topics inside Kubernetes, then we will be able to understand about various things in detail. So this slide we understood pods are the smallest unit of Kubernetes, and they will have containers inside them deployed. So this can be considered as a pod, and here you can have container 1, container 2, and the preferred way is to have one main container, say C2, and other can be lightweighted helper container one can be init container that can start and do the task, and then main container start using the task that init container actually did as a pre-work for the main container. Then you can have sidecars or helper containers too that this main container will be using during its life cycle. So pods have their own life cycle. They can be creating, container creating, running, or stopped. So these kind of stages pod covers during its life cycle when it is deployed onto a Kubernetes cluster. Next is services. Now you have created pods, and the pods that you are creating is not only one replica. You are creating multiple replicas of pod. How you will access these pods? You have 3, 4, 5 replicas, same copy of application pods are running. Now how you will understand, or how you will route the traffic, or how will you make your pods accessible to the end users? This work is done by services inside Kubernetes. So services are used to load balance the traffic among the pods. It follows round robin distribution among the healthy pods, and this way it routes the traffic one by one to every healthy pod running in the network. So the second question is how services know which pod or which set of pod they need to redirect the traffic. This is done using a very basic concepts of labeling inside pod deployment file. Okay, So whenever deploying a pod, you create YML, or whenever you can create pods deployment from command line also, there you define a label for it. So in labels, you can mention, suppose I am deploying Nginx pod, so I can mention label and app is equal to Nginx. So this way, whatever replicas, say 3 replicas, this pod is running. So this service will know that I need to route all the traffic intended to Nginx pod by using label selector. Label selector as Nginx. So make sure when you are deploying pods, they have unique labels if they are not a replica of same pod. So labels are very strong way of selecting or routing the traffic between multiple deployments, multiple pods running inside a cluster using services. So this was about services, and next is ingress. So ingress is very niche term in Kubernetes if I say in terms of implementation. Many people fail to understand the concept of ingress, what it is. So let's understand what ingress is. An ingress is an object that allows access to your Kubernetes services from outside the Kubernetes cluster. Using a service, you can access your cluster inside or outside. But having service deployed for every deployment that can be accessible outside need a load balancer, and that involve cost. Ingress provide a cost-effective way of accessing your cluster, accessing your application pods outside the cluster. And this is where we get the ingress implementation done. You can configure access by creating a collection of rules that define which inbound connection reach which services. So if you can see, you have two applications deployed in terms of pod. Each application has 3 replicas created and running. You can see blue and purple replicas deployed here, and each pod deployment set of pods has their own service, blue service and purple service. One blue service is our image application, and service purple is our video processing application. So now how you can, if you want to access this service outside, you need to create each as a load balancer service or node port service based on your deployment type, bare metal or cloud. If you don't want to go by that, because having load balancer for each service is a costly affair, so that's where a cost effective alternative is provided by ingress. Now ingress, how does ingress do this operation? When you define an ingress, it is again a YML first of all. In this YML file, you actually define backend or backend rules. If you know about Nginx, most popular ingress controller is Nginx first of all. So Nginx is able to route the traffic very intelligently based on the backend rules. Routing rules you can say, or backend rule you can say. So same way, same concept we have here when we talk about ingress. So ingress rules are created which actually have various backends where they want to route the traffic, and each backend rule defines a service. So say here we have two services. So one we can say image service, that is blue one, and one is video service, right? That is the purple one. So each rule will have each rule will have a specific service name mentioned and its port where it need to go. Now whenever traffic comes, whenever application URL has /image, it is called path based routing, right? So if that application URL has suffix as image, it will go to image service and it will be served by blue pods that are deployed and running here, right? This blue service is pointing to blue pods or image pods. If this URL has URL suffix as video, then it will go to this service, and this video service is already pointing to purple pods, and this way the purple pods will do the video processing and give the required results to the end user. So this is way backend rules are helpful. So this is just a basic of ingress. There are various other advanced ways of configuring your backend rules. You can define your host, which should route to which service. So these kind of intelligent routing you can do using ingress deployments in Kubernetes. Okay, so this was all about three basic important components: pods, services, and ingress that we discuss in topic. In next session, we will try to implement the same concept. Okay. We already discussed about pods, which is a smallest unit in Kubernetes deployment. Now we will see how we can manage pods using a deployment that will manage the set of pods more efficiently than single pod deployment. What is deployment? Deployment in Kubernetes is a controller which helps your application reach the desired state. The desired state is defined inside the deployment file. The desired states can be replicas, can be the resources, can be the health check. So these there are various parameters that you can define inside deployment to manage your pods more efficiently than individual deployments. How a deployment is created? You can create deployment using command line where you need to write a long command. So the preferred way of writing deployment, like I said, Kubernetes, everything can be written, the YML deployments, and they can be created using kubectl apply or create. So similarly, deployments also can be written in terms of YML file, and you can see a sample YML file on my screen. This YML file will deploy 3 pods for Nginx and will maintain the desired state, which is 3 pods. So here the desired state that I want to be maintained is 3 replicas for my Nginx pods until this deployment is deleted. If you want to uninstall this deployment, you don't want those pods to be running completely, you can simply run kubectl delete, kubectl or kubectl are same, delete, and then the deployment name. This way this deployment will be deleted and pods will be removed. So how a deployment YML starts? Every kubectl YML actually starts like this. It has API version that you need to mention in every deployment in every YML definition, be it a service, be it a pod, be it deployment, be it ingress controller. So every object need to be defined like this. First you need to define API version. In case of deployment, it is apps v1, for pod it is v1. So depending on the component, the API version changes. Kind is deployment. So here the object type that you are defining, you give inside kind. If it is a pod, you give pod here. If it is an ingress, you give ingress here. If it is a service, you will give service here. So this way kind is actually used to define the type of the object you are going to create using this YML. Then comes metadata. In metadata, you define information about the object that you are going to create. Here it is deployment, so I am giving it a name. Name is important to provide inside metadata. Next, other things are optional. So name is important because using this, it will be identified inside the Kubernetes cluster. In name, here we are giving Nginx deployment because we are creating Nginx pods using this deployment. Then labels is important. It is an optional one, but in order to run multiple deployment inside your cluster, you need to provide labels. It is important so that you can segregate. Name is one thing using which you will segregate the deployment, but you have multiple pods that may have same name or maybe same services they are providing, or maybe if you want to bundle them in different groups, then this labeling is important because that's how the service pointing to the pods will identify which pod it need to redirect the traffic. Right? Then comes specs, where you will be mentioning the details of the deployment or objects that you are going to create. Here in deployment case, we are defining the replicas, how many number of pods this deployment need to ensure while this is running in the cluster. Then selector actually is used using which this deployment monitor the pods. So here also see labeling is important because using this label only it will create the pods and manage the replicas and other things about the pods. So suppose this deployment created 3 pods and these pods doesn't have any label, right? So how they will be managed by this deployment? So using this label only it will do. So in selector actually you define which label pods this deployment will manage. Next, we need to deploy, we need to mention this label when we give definition of pod. What we do in template, actually we define our pod specification, pod details. First is metadata, where we are mentioning the pods label and other metadata about it. We can mention the name, we can mention labels, we can mention other in labels we can mention other important details like application we are mentioning, we can mention category, we can mention other details like we can say front end or we can say back end. So these kind of labeling we can do here, like type front end, type back end. So multiple labels also can be applied here. Then now you can see this match label and this app pod label need to be same. Here you are giving the name to your pods, and here you are saying your deployment that these pods with this label need to be managed and 3 replicas should be ensured during life cycle. Specs, you give your pod specification. Every pod need to have at least one container. So in containers tag we need to define the same. You see here we have containers, not container. That means you can define multiple containers inside your pod specification, right? So here you need to give a name of your container that you are going to define and run inside the pod. Then the image of the container from which this container will be fetched and running. Then the port, if this pod need to exposed on a port, because Nginx need to be exposed and accessible outside on port 80 or any other custom port you want. So this ports mapping also need to be mentioned here in the pod specification inside deployment file. So this whole section in template is your pod deployment, pod specification. If you are going to create pod independently also, then this information will be picked, including API version and kind. This is a typical deployment file that we'll be doing and deploying in our hands-on session. So these are various sections, especially 1, 2, 3, 4 that we typically have in most of the Kubernetes deployment or Kubernetes object definitions or YMLs. So let's create this deployment in our VMs in control pane and Kubernetes cluster that we created in our Kubernetes installation exercise. Fine. So I have a document available for this, and here I have same definition or YML file available. So you can see clear indentation mentioned here, API version, kind, metadata has name and labels, label has one label app, then specification has a deployment specification, parameters, replicas, selector has match label, which label to match, app Nginx, of what, of pods that this deployment is going to create. Now template will have your pod definition. This is pod metadata, so you can see both metadata is different. This is for your deployment, this is for your pod again. This metadata need to have this label that deployment is going to match. So label I am giving same app Nginx. Then the pod specification need to have containers, minimum one container required, then the container name and the image and port. Let's copy this deployment file and create on my master node. Okay, so let's create deployment.yml with the content. So you can see the indentation is more clearer in this text file. API kind and two spaces are required when you are making an item inside the parent item, right? So let's save this. This is going to be an Nginx deployment because Nginx image is used here. So let's create this deployment. How? You apply -f, and the -f means you need to provide the input as file name and this. and it is very quick. You can see the deployment has been created. You can check the status now using get deployment. Here you can see name of the deployment, ready 0 of 3, up to date 3, available 0. So this deployment has been created, but the pod status has not been available yet. How you can get the pod status? Using get pods. You can see now when I ran this command, the available pods were 0, but now when I ran, 3 pods are started and running well. 1 of 1 ready. Here you can get the ready status of the pod also. Every pod uses deployment, actually it uses deployment name and then some random string, correct? So this way you can check again the deployment status and you will see ready 3 of 3 and available all 3. Suppose I delete this pod. So let's see how deployment manage the number of desired replicas. Let me delete this pod. How we can do this? Using kubectl delete pod. Commands are very simple and easy to keep in mind. Let's delete this pod. Okay. What will happen? I have deleted and you can see I deleted the pod, this one. This is not available here, but still I have 3 pods running. And one is just 10 seconds older. So deployment, this is a magic, and this magic has been ensured by the Kubernetes deployment, where it will whatever pods go down, crashes, resource issue, any application issue, the deployment will try to start a new pod and in healthy condition. So this is a usefulness of having a deployment to ensure your application desired state always in the Kubernetes cluster. So Kubernetes deployment created, we were able to check the pod status. In short, you can run PO also for pods. So you can run 3 ways. You can run get pods, you can run get pod, or you can run get po. All these 3 commands are alias to the same command. These all 3 will return the same pod status. What if you want to get status of all the deployments, everything you did, not only deployment, everything, pod deployment, services, everything. You can just run kubectl get all and you will see whatever things are available inside it. This service I have not created. This is the service created by Kubernetes. I have not created any service yet in this tutorial. So this is a Kubernetes default service that is running inside the cluster. Then this deployment I created, these pods I created, and this replica set get created as part of your deployment internally. Replica set is actually ensuring this task of keeping desired number of replicas running in the cluster. So this is how various components managing the desired state of your application deployment. Fine. So this was all about deployment, right? Next session we'll discuss and cover about service. In previous topic, we already discussed about service. A service is created in order to balance the traffic between set of pods. So let's see how we can create our own service and manage it to and use it to manage our communication with the backend pods. So before that, let's see what service is. A service is basically a round robin load balancer for all pods, which matches with its name or selector. It constantly monitors the pods. In case a pod gets unhealthy, the service will start deploying the traffic to other healthy pods. So by default, service will not create a new pod. It is the job of deployment and replica set. It will just ensure traffic is going to healthy pods in round robin manner, and if any pod goes unhealthy, so it will just mark this pod inactive and will not route the further traffic to the pod. Okay. So this is how service works inside a Kubernetes cluster. What are the type of services? Kubernetes actually gives you 4 types of service based on your requirement or uses. First is a basic one, that is cluster IP. it actually exposes the service on cluster internal IP. Using cluster IP, you can access the service inside cluster only. It will not be accessible outside. So if you don't want your service accessible on the from the cluster outside, then you will use cluster IP here. Now, if you want your service to be accessible outside, there are two ways: node port and load balancer, and both have their own scenarios to be used. Node port is used when you want to expose the service on each node's IP at a static port. So if you have a VM that is running in your own environment, bare metal machine or VMware machine, then you can use node port. It actually mounts your service to a node's IP. Node's IP means your VM's IP. So it will just use your VM IP and uh, map your service to the port on your VM itself. That's why we call this service as a node port. As the name suggests, it is using your node's port, your VM's port only, to route the traffic to the backend ports. So this is where node ports comes in picture. Then comes load balancer. This also exposes your service externally. Node ports also exposes your service externally, and load balancer also exposes your service externally using a cloud provider's load balancer. So this is a preferred way of using service or deploying a service when you are using your VMs on cloud. So it's preferred always to use load balancer service when you are using a cloud instance to deploy your pods and create a service, because load balancer are automatically created in your cloud service provider's environment, and you do not need to take care of additional steps to create load balancer manually. Okay, so this way load balancer service will be used when you are using a cloud VM. To create this service, functionality is again same. You want to access your pods outside the Kubernetes cluster. Fine. Then comes external name. This is again a type of service that maps the service to the DNS name mentioned with the external name service. If you have a DNS name, external DNS name, and you want to map that DNS name to the pods or service inside the cluster, then you will be using external name service defined here. So let's see some of the scenarios using the service implementation. This type of 4 services actually have their own use cases, and we will not be able to implement all the use cases here. We will try to implement cluster IP and load balancer because we are using Google Cloud machines here. So this cluster IP can be created inside the cluster, and load balancer I will be using here. So because I am using Google machine, which is a cloud instance. So let's create a service here. So because it is a VM also, so node port can be, one thing I need to tell you, node port can be created on both cloud machine also on or on local machine also in your local environment. So both where node port will work, and you can access on the VM's IP address and port. Similarly, load balancer also can be created on both the machines, cloud instance and local in your own environment also. But for your own environment, load balancer need to be taken care manually. So let's go to the lab exercise and try to create a node port service as part of our deployment. So I have a doc again to follow and create various type of services in the exercise. So first we will create a node port service that will point to my deployment pods that I created in the deployment steps. So remember, we created a deployment, Nginx deployment name, and that is running successfully in our Kubernetes cluster. And you can check this here. You can check again, my pods are healthy and running. Let's create one node port service using the command line. We can use deployment file also, but this is a basic command that we can create a node port service or any service just by changing the type here. Instead of node port, if you want cluster IP, you can change cluster IP. If you want to use load balancer, you can create load balancer here, and this will be the name of the service you want to create. And here you do host to container port mapping, like we did in the container or Docker tutorials. So this way actually it will use the command kubectl create service. Command is simple, right? And then the type of service and the name of the service and the ports need to be mapped if required. So let's run it. And sorry, I think what is missing, got two. Exactly one name is required. Let me see if something is, I think this is because of this flag. Oh, this should be hyphen hyphen. Okay, so this was the error. Service Nginx created successfully. So let me update this document. Problem, this should be hyphen hyphen. Okay, so we have successfully deployed our service, and let's see the service status. How we can do that? Get service, or we have a shorthand also using SVC. So both way you can check the service status. This was the service that was running by Kubernetes for internal purpose, and this is the service that I just deployed 25 seconds ago. You can see one internal IP has been assigned, cluster IP, but external IP is not assigned because it is using your nodes IP. So that's where you will not see any IP assigned here. Okay, so this is the configuration of node port service. Fine. So let me check one more thing. Here you can see in ports. Here your port 80 of application can be accessible using nodes port. And what is the nodes port? 32375. This is the port of your host VM. This virtual machine is getting mapped to the port 80 of the pod. Okay, so let's try to access this service. We already have curl here, HTTP. First I need to get the IP of my host machine. If config a, this one is the IP, HTTP, and the port is 32375. 32375. Curl. See, this way my pods port 80 can be is mapped with the IP of the host or nodes IP. If you want to check this port usage on VM, you can check using this command ulnp rep port 32375, and you can see this port is getting listened. Application check, I need to put sudo to run as root, and here you can see kuproxy is using this port to map my communication with the Nginx pods. Same command you can run on web also if this is accessible outside. And your service should be accessible here also. Since it is a cloud machine, I need to open this port. That's why you will not see it is accessible here. I can go here in firewall, networking and firewall. Here it is. In firewalls, I can go and edit the port. I need to add the ingress for this port, then only I will be able to access outside. So this is an additional step. I can use it or not. Let me, since I have opened it, I will try to show you by changing it. Let me edit this firewall rule, Ethereum, and I can add port here. Okay, updating. I can go back to my VM. Yeah, rule is saved. I will go back to my VM. edit this kube master and kube worker both. So I will edit one. Actually pods are running on kube worker, so let's edit this. Go inside this and add the file rule by editing the VM and add the tag here in network tags. Okay, done. Save it. Now we have made the firewall changes and I should be able to access it outside. It is saving. So let the VM save the changes and then we will see if this is accessible or not. Changes are saved, right? It may take some time to reflect the changes. Meanwhile, we can do something else. I will add these changes to master node also, because from master communication will be going. Let's edit the master VM as well and edit this firewall rule. And click on save. So until it takes time and to reflect the changes, let's move further. What is next? We have created node port service and we're trying to access it outside. That is the end goal of this exercise. Cluster IP service we will create in the next session where we discuss about ingress. This is not getting accessible by, this is the IP. Oh, I'm not using the correct IP. I am using internal IP. So outside I need to use this IP of the node. Port opening is important, that is one thing, and using correct IP. I need to access outside I need to use public IP, and this where you can see Nginx is accessible now. So this is how we can see using node port I was able to access my Nginx deployment. One more thing I would like to show you here. I will try to deploy one load balancer service also. Sorry, this is my slave node, this is my worker node. So this is my master node. So let's create one more service, Nginx 1, and let's do it a load balancer one. Created. Okay, let's get the status of it. This is also created, and now you can see it is getting an external IP assigned. Load balancer in cloud by default get created for load balancer service, and they expose your service externally by giving you external IP of it. They give external IP assignment, and that's where you see it will be done. It's taking time, it may take some time, so let's go back to the next exercise and we will try to check after some time what is the status of this service, because the process of IP assignment by the load balancer takes some time. This we will check in next session. The next session is about doing and learning about ingress. In this session, we are going to learn about ingress. We already saw some basics of ingress in the previous slides. Now we will discuss about in detail. What is Kubernetes ingress? It is a collection of routing rules that govern how external users access services running in a Kubernetes cluster. So here you define your rules, routing rules, in terms of backend, which backend that particular rule want to target a service. So in backend actually we give the service name as I explained earlier, and based on the path suffix, ingress rule actually forward the traffic to the particular service. So this is where we can write multiple rules inside our ingress definition, and based on the rules definition, the traffic will be routed to the particular application. And that's where only one ingress you can see can be able to manage traffic to various deployments and various services without having multiple configuration and consuming multiple resources, right? So how ingress work? Whenever you deploy an ingress, it need to have an ingress controller in the cluster already. Without having ingress controller, which is a CRD, custom resource deployment, so that need to be deployed on your cluster in order to monitor the ingress rules that you deploy here for every deployment or any or multiple deployment inside your cluster. Whenever you create any ingress rule, this ingress controller actually will monitor those rules and create their entry in the based on the backend rules that you define here in ingress rule. An entry will be registered in the ingress controller's configuration file based on which it is doing the routing job. Ingress controller, the most popular one is Nginx, Nginx Plus, and other are provided with the cloud also. You can have a Google Ingress controller. You can have, if you are using AWS, you can have their AWS load balancer, ingress controller. So these kind of various load balancers are available based on your requirements. You can select one. Now, when ingress controller you deploy in the environment, how they will be accessible outside? They also create a load balancer or node port service in your VM based on the deployment or VM type. If you have a cloud VM, then they will create load balancer, or it is preferred to create load balancer. You can create node port also. And if you are having on own local machine or in your own IT environment data center, then it is preferred to use node port of the IP of the local machine. So both way, node ingress controller can be exposed to the outside users, and this ingress service actually, the node port service that we created earlier or load balancer service that we created earlier, can be used to accept the incoming traffic and forward those traffic to the backend pod. Now you can see when we are using ingress, we have to first of all have an extra deployment of ingress controller that will manage all the ingress rule to register new rules. If you are deleting this rules deployment, then deletion of also will be done automatically, and you do not need to do anything. This is full automation of registering your services for the backend traffic, outside traffic, external traffic. So this way also you need to create one. When you are deploying ingress controller, it will create one ingress service that will accept incoming traffic from the external user. Once it is received, the ingress controller will check the definition file based on the backend rules and route the traffic to particular service. If it is a video suffix path, it will send to the blue pods and service. If it is a backend, like it is a image processing related query, means having a slash image path in the suffix, then it will send the traffic to the purple pods or image processing application. So this is how ingress will help you routing the traffic to the correct application pods, right? And this operation is fully automatic. You need to deploy this. You need to deploy a service, create service of cluster IP. Any other type you do not need to create here. This is completely unnecessary. It may work, but having a cluster IP is only required. So because it need to communicate internally, ingress need to communicate internally with the service IP, because both are part of the same cluster. Ingress controller cannot be part of the any other cluster. It need to be part of the same cluster only, and will be able to access all the services it is managing using this ingress backend inside the same cluster. Fine. So this is the traffic flow, and we will try to deploy the same kind of scenario in our lab exercise. So the basic requirement for having an ingress created for any deployment, we need to have ingress controller created for our cluster. We need to have only one Kubernetes ingress controller deployment cluster wide. Okay. So when we deploy an ingress controller, it actually deploys daemon sets. Daemon sets are other kind of deployment where only one pod will be created. Non-privileged pod, I must say, will be created on every node of the cluster, every slave node, and every master and slave node in the cluster, so that it will monitor the all ingress rules inside the cluster that are being deployed. Okay, so this is the link where you can go and follow based on your flavor of machine that you have. Let me go here. I have clicked this, and you can see ingress controller type may vary based on the machine you are going to create it. It's like the type of cluster, the host environment for your cluster you have in place. Like for Docker, it may be different. Minikube, it may be different. Micro-K8s, AWS, you need to have different ingress. For GCGK, need to have different ingress. For Azure, so for every platform has their own variety of ingress based on their architecture, and that's what you need to choose. Because we are using Google Cloud instance here, so we are going to use the one I have mentioned here. Okay. So let's create this Nginx deployment on master node. Let me get if this is again pending. Okay, so let's leave it as it is. We are not be using. What I need to do, I need to again use kubectl apply on the YML file of this Nginx ingress controller. Okay, ingress Nginx it is mentioned. I can go to this path and show you the deployment file as well. Let me open this here. I can quickly show you what content it will have. One deployment for YML can have multiple objects separated with the, because one YML file can have multiple YML definitions separated with this hyphen. Okay, this is where you can see this YML file has a namespace. You can create, it will create a namespace. Okay, namespace name will be ingress Nginx. It will create a service account also. So every object definition is separated using this 3 hyphen. Then config map will be created, cluster role. These are all separate objects required for this ingress controller functioning. Okay, cluster role binding, role are required to access the ingress and manage it. Role binding will be done with the respective users. Then service will be created. That service I talked about, right? And then a service is getting created again here that will route the traffic to for 80 and 443 for HTTP and HTTPS ports. Different services are getting created. Then deployment is getting created for the deployment of resources pods that will manage the ingress rules or ingress deployments. And then you can see last you will see one. There are a lot of things that are getting created. Okay, and this is where we will see our definitions when we deploy it. So let's deploy the same on our master node control plane. You see everything is getting, we saw now namespace, service account, right? And everything is getting created. And here you can see this is using your deployment, not daemon set. So this may have, so daemon set is not getting created. Instead it will have multiple pods on same nodes to serve you better with multiple replicas. So deployment and daemon set differs in terms of their usability. If you want only one pod on per node to perform some kind of helper service or give some support service to the deployments, then you go for daemon sets. And if you want to have multiple replicas of pods running, then you may go for deployment. And there is another term also, stateful set, that is used in different purposes, that is not part of this course. So everything is deployed where, if you remember, this namespace was created. So our resources, if I try to check here for ingress controller, I will not be able to check anything about this controller here. I have all the things that I created in previous session. But for Nginx, where I need to check in this namespace ingress Nginx, right? This is how Kubernetes actually separate deployment in namespaces, which is called virtual segregation of things. So you see this pod actually completed means there's no issue. The things that they had to do is completed, and they do not need to be running forever. Then this ingress controller pod is running, and this will be taking this will be monitoring all the resources on your clusters for every ingress deployment. You can see one ingress controller running here, and if you go and check how many pods I had in this definition file, in deployment, you will be able to understand this. Let's check for the deployment. Yeah, this is my deployment, and here I can see how many replicas I am creating for this deployment. This is my spec template, and okay, so they have not given any replicas. That means only one replica will be created, right? So if you are not giving replicas, the deployment will consider only one replica. That's why I can see one replica here created. So what next? It created two services also. One is node port and one is cluster IP, right? So this is a simple VM. So that's why it is not using load balancer. It is using node port here, based on, because I have deployed a bare metal. If you see, go and check here, I have deployed a bare metal type of ingress controller. So it is, that's why it is creating as a local hosted machine of my virtual machine and creating a node port service. So this makes sense, right? As per our discussion we did about services. Next, so we see services deployed, deployment is here, everything deployed here. Now next, what we need to do, now my cluster is ready to register ingress rules or ingresses that were part of our this tutorial, right? We got this created, ingress service node port is created here. If you see, this service is created, this one, right? And now we need to create this and this. We have we created a node port service from which Nginx was accessible, but now we will create a cluster IP service, because for external service, for external access, we have this ingress available now. So let's go and create a cluster IP service. This is done, right? And this service I already deleted. What next? I will create a cluster IP service Nginx in my environment, my cluster. That will point. So everything remains same, just type of the IP I have changed to cluster IP. And let's see kubectl get service, and you can see this cluster IP service is created with the internal IP, and this will be used as a backend for my ingress rule. So let's create one ingress rule YML. This is a typical ingress YML that I will be using here. It again has a API version, kind will be ingress, metadata, name of the ingress rule that I am creating, annotation is required because that will be letting me what resource I need to use for this ingress creation. Then in specification, I basically need to define the rules. This is the important parameter that I need to provide here, and rule I need to give HTTP or HTTPS. The type of protocol need to be mentioned. If I am going to use on our secure protocol HTTPS, then I have to add HTTPS rule section also. This is a list. Rule is a list, so that's where I can add multiple entries. So let's go and create this ingress file on master ingress.yml, and it is more clear, so I will explain here. This rules has a port type and then paths. This need to have paths, and paths is again a list. In paths I can add multiple paths, like for image I can have image here, other path I can add like video. If you go by the example here, one is image, so this can be considered as image, and I can add one more path, append here, and I can add /video. So this way, if traffic is coming for image, it will go to the image service, and if it is coming for video, it will go to video service. And then path type I need to mention prefix or suffix. Okay, so this is one thing. Then backend is important, to which service the backend will be pointing. So this is 1.20 version I am using. Here backends have some what changed. So this is where you see different patterns. Earlier version of till 1.19 actually it was very simple. Just in HTTP routes you can define rules and backend and the service name. This was simple YML being used, and in 1.0 it has become a bit changed. So in backend you give the service name and port. This part was part of the HTTP directly earlier. Now they have mentioned something different here for additional features. So that's it. You define the service name. If we go by this example, so here I need to give this service name, blue service here in image. Sorry, blue service in video and purple service in image. So this is how we define it. So because I'm using Nginx here, the reason is my cluster IP's name is Nginx, right? And the port it is using is 80. So this is my ingress definition, and let's create it using kubectl apply -f ingress .yml. You see the service IP, the service cluster IP that this ingress need to point is Nginx. The same I have used. Oh, there's a typo in apply, and the ingress is created. Let's check the ingress, how you can do it using ingress, or in ing also will work. So you see my ingress has been deployed, and I can check for the service IP. First of all, this ingress is using my node port IP. So this node port IP is this one. So using this IP and this port, now this ingress can be accessible. Any service that I deploy will be accessible through this IP only. This single IP will be used now, and port will be used to access any service with the prefix and the backend rule. So this is done. Let's try to access this internally first, and then we will try to access outside the cluster. The IP is this. Sorry. This is my node port IP, should be my local IP, right? That I need to get first. If config -a, this is my local IP, curl http local IP, and then the port was this one, 31122. /nginx, because this suffix is required, prefix is required. Using this I am able to access. Suppose I remove this path. See, this is not accessible. Now there is no backend rule defined. If you go with the definition, I have mentioned this path /path should be appended, and this path will redirect my traffic to the Nginx service. If I remove this, remove this, there is no page form. So this is the default behavior. Let's try to access outside. So this was my IP, and here this was for previous service, right? Let's open a fresh one. Let's copy the port node IP, put it here, and 31122. The result you can see not found here because I have not entered the prefix that I mentioned as Nginx in the ingress rule. So if I mention Nginx here, the routing is correct. It is able to access the service Nginx that I created inside the cluster, and it is able to reach the application successfully. So this was all about the ingress controller and ingress that we had to cover in this session. Next topic, we start with the Nagios, that is a tool for continuous monitoring. Till then, keep learning and keep tuned. Bye bye. So clearly, the rescue operations are going on for the third consecutive day, and you can see the visuals that how one of the NGRF vehicles carrying several of the NGRF personnel and several equipments have arrived at this site, even as the workers are working continuously to go through the debris and still look for some of the dead bodies, even as the death toll in this deadly crash has reached 275. So clearly, the rescue workers are having a tough time over here to look for more dead bodies. Even on Saturday afternoon, the rescue workers were able to bring out three dead bodies from the tail section and other debris over here from this crash site. And one of them was of the crew members of the ill-fated Air India flight. So clearly, the investigators are probing the main reason